Once the preferred site is established, the next step is to look at the soil profile and the strength of the soil. Each cubic metre of water weighs about 1 tonne, so the soil has to be strong enough to hold that weight and not breach due to low strength. A tool called a scalar penetrometer measures the strength of the soil and gives a rough idea of the soil structure.
Obviously this is a very soft soil, and you can see from the results that I'm getting that the soil is not stiff and is probably a peat type soil.
Another quick way to see what's beneath the surface is to use an auger to take core samples down through the soil profile to ascertain whether it's suitable for a foundation or can be used in the construction of the pond.
The soil that we've pulled out from the top is a silt. We've now reached a depth of 850 millimeters and have encountered a different type of material. This is a brown silt, possibly containing clay. To actually ascertain whether it's going to be suitable, we would probably have to take this back to the lab. We can also, in the field, do a couple of simple tests just to see what the material may be. One of the simple tests we do is a pat test. We'll be patted very gently. If the water comes up to the surface as it has done here, it indicates that it is silt. The other test that we can do that is very simple is called the roll test. If we can get this to roll down to a 3mm diameter worm, that would indicate that it also has a clay content. But to verify this, we'd have to take a sample in a push tube and probably a bulk sample back to the laboratory and do further testing there.
Once a trench is dug, it's easy to see the soil profile, and this allows a larger sample to be taken, using the digger to push the tube into the soil. Taking it out again is done the old-fashioned way. In the laboratory, the samples taken on site are tested for permeability to make sure the material is suitable for pond construction. The standard required under regional council rules is usually a permeability rate of 10 to the -9 metres per second. Specialist instruments are also used post-construction to make sure it's up to a safe standard. A nuclear densometer measures the density of the material to ensure it's compacted, and a Pilcon shear vane is pushed into the ground and twisted to give the shear reading and the strength of the material.